In this video, we will go over the resonance structures of the chlorate ion, ClO3-. So the first thing is we have to determine how many valence electrons, outer electrons, we're going to put to construct this molecule. So we have chlorine, which is a halogen, happy at 7. Oxygen is happy at 6, but we have 3 of them for 18. And then that minus sign is indicative that this structure, in order to become the chlorate ion, has gained 1 electron. So our goal here is to get 26 valence electrons around the chlorate ion, or chlorate anion. Let's make chlorine our central atom, because we don't know which one of the oxygens is going to be center. So with chlorine as our central atom, and we have 3 oxygens here. So let's remember one thing here. In order for oxygen to have a minus formal charge, okay, forget about the R for a moment. For the oxygen to have a minus formal charge, and remember this whole molecule has a minus charge, so forget about the R. If we have a single bond to the oxygen with 3 lone pairs, that actually has a minus formal charge. Remember, 1, 2, 3, 4, 5, 6, 7. Oxygen is happy at 6. 6 minus 7 is minus 1. So that is the formal charge of a single bond substituent to an oxygen atom. So forget about the R, just focus on the oxygen. This also satisfies the octet, right? 1, 2, 3, 4, 5, 6, 7, and 8. Now, on the flip side, if you have a double bond to an oxygen, something that has a double bond or double bonded to an oxygen, basically what I did is I moved a lone pair of electrons to create that double bond, and I will keep these 2 lone pairs. This has a formal charge of 0, right? So 1, 2, 3, 4, 5, and 6. Oxygen is happy at 6. 6 minus 6 is 0. This also satisfies the octet, right? 1, 2, 3, 4, 5, and 6. Oxygen happy at 6. 6 minus 6 is 0. This also satisfies the octet, right? 1, 2, 3, 4, 5, 6, 7, and 8. So this also satisfies the octet rule. So the main point I'm trying to convey here is if you have anything with a single bond to an oxygen, it will have a minus formal charge. If you have anything that's a double bonded to an oxygen, it will have 0 formal charge. So coming back to the ClO3-, there's going to be 1 minus sign into it, so that's going to be a single bond oxygen. Kind of like following this example, my R is the Cl. I'll make a single bond oxygen with my 3 lone pairs. Okay, and then my other 2 oxygens, I'll make a double bond. So let's make sure we have 26 valence electrons now. So we're going to have to count everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I'm going to put 25 and 26 on the chlorine atom. So 3 bonds, 1 lone pair on the central chlorine. Don't forget our formal charge. 1, 2, 3, 4, 5, 6, 7. Oxygen happy at 6. 6 minus 7 is minus 1. Okay, we already know that as anything with a single bond to an oxygen will have a minus formal charge. What about the chlorine here? Okay, so I got my minus 1 over there. Formal charge of the chlorine, 1, 2, 3, 4, 5, 6, 7. Chlorine is happy at 7. 7 minus 7 is 0. So this would be the best representation of the structure. You see my minus sign is accounted for here. All right. Chlorine here will have an expanded octet, but that's okay. It really doesn't matter. This is the best structural rendition because the minus formal charge is accounted for. The minus formal charge on this oxygen can also be delocalized. It can be delocalized on this oxygen as well as this oxygen. By that I mean the single bond does not have to always be on the right-hand side. It could just as well be on the top or the single bond could just as well be on the left-hand side. And that is the epitome of resonance. So let me draw it so that the single bond is on the top. In order to do that, I'll move this pair of electrons here, kick that pair of electrons out there. So formal charge, negative formal charge is on the topmost oxygen. The double bond oxygen is here. And then finally I can have the single bond to the oxygen on the leftmost oxygen. So in order to do that, I'll move this pair of electrons here, creating a double bond, kick out that pair of electrons to that oxygen. So then I will have here as my final resonance the minus formal charge on the leftmost oxygen. Now the double bond is here. The double bond on the rightmost oxygen stays the same. So that is the resonance structure of the chlorate ion. Minus formal charge here is accounted for. The formal charge on the chlorine, the central halogen atom, this is the center atom, is 0.